elements. Rare earth elements.
Rare earth elements.
Rare earth elements.
Rare earth.
Rare earth. Rare earth.
Rare earth.
Rare earth.
Rare earth.
This is yttrium oxide. It's a rare earth element which has been bound with oxygen, and it's one of 7 rare earth elements which China this year has restricted the export of.
China has a stranglehold on the metals that power the modern world. If they decided to cut off the supply tomorrow, factories across America would shut down within weeks. It sounds like a doomsday scenario, but it is a real threat. However, the solution might have been hiding in plain sight the whole time. Deep in the mountains of West Virginia, polluted rivers are flowing with the very thing China is trying to restrict. Scientists have cracked the code to get it out. But it is not that simple, though. Turning this dirty water into a stockpile is sparking a silent battle for control. The orange water that could save the economy. If you had walked along Decker's Creek in northern West Virginia some years ago, you would have seen a landscape that looked more like Mars than America. The water did not run clear or blue. It ran a harsh, bright orange. Locals stayed away. There were no fish jumping in the current, and you certainly would not want to dip your toes in it. The rocks along the bank were stained red and brown, and a sharp metallic smell hung in the air like old pennies. People called parts of it a cesspool. It was a dead zone. For decades, everyone thought this was just a tragic legacy of the coal industry. When mining companies dug tunnels into the mountains and then walked away, they left behind miles of broken rock. Inside that rock was a shiny mineral called pyrite. You might know it as fool's gold. It looks pretty, but when it meets air and rainwater, a chemical reaction starts. The pyrite turns into a nasty form of acid. That acid eats through the surrounding stone like sugar in hot tea, dragging heavy metals out with it. This rusty, acidic soup, known as acid mine drainage, pours out of the old tunnels and flows straight into the creeks. For a long time, this was just seen as garbage. It was a problem that cost millions of dollars to fix. It corroded pipes, ruined drinking water, and destroyed property values. But here is the catch. When chemists and geologists finally decided to test that dirty water with modern equipment, they realized we had made a massive mistake. The acid was not just pulling out iron and aluminum, it was stripping the rock of rare earth elements. These are the 17 magic metals that make the modern world spin. They are in the magnets that drive electric cars. They are in the speakers of your smartphone. They are in the guidance systems of smart bombs and the engines of fighter jets. And for years, we let millions of pounds of them wash down the river. A group of scientists working with the government looked at the data and were shocked. They estimated that the drainage flowing out of coal mines in the Appalachian region alone could carry thousands of tons of these materials every single year. We are talking about a volume that could equal almost half of what the entire United States uses in a typical year. It is not that simple, though. In a normal, clean river, these metals stay locked inside the rocks at the bottom. You cannot get to them. But the acid from the mines acts like a natural chemical plant.
Roughly 12.2 miles, it's a viable fishery. We've got a healthy trout population, partly due to the stockings of a local hunting and fishing club upstream. But as I said, downstream is dead.
It dissolves the metals so they float freely in the water. Nature had effectively done the hardest part of the mining process for us. It did the digging, the crushing, and the initial dissolving. All we had to do was figure out how to catch it before it washed away. The crazy part is that we have been building treatment plants to clean this water for years. We add chemicals to neutralize the acid, which turns the metals into a solid sludge that settles at the bottom of a pond. Then, we pay trucking companies to haul that sludge away to a landfill. We were literally paying people to throw away a fortune. When researchers at West Virginia University tested that waste sludge, they found it contained concentrations of heavy rare earths that were better than some commercial mines in other countries. In northern West Virginia, every ton of that dried orange mud could hold nearly 2 pounds of rare earth elements. That might sound small, but in the mining world, that is a bonanza. Suddenly the conversation changed. This was no longer just about cleaning up a dirty creek to save the trout. It became a hunt for strategic resources. If we could capture these metals from the water we were already treating, we could create a domestic supply chain that did not involve digging massive new open pits or destroying new land. We could heal the environment and arm the economy at the same time, but realizing the potential was only the first step. The real challenge was figuring out how to separate the valuable rare earths from the mountain of junk metal floating alongside them. And as scientists began to crack that code, they realized they were sitting on something that could shift the balance of global power. This resource is easy to access. It is everywhere in coal country, and it refills itself every time it rains. But to get it out, they had to reinvent the way we think about mining. The water was waiting, but the clock was ticking on a much bigger stage. Science fiction technology in a West Virginia mine. It is one thing to find hidden metals in river sludge. It is a completely different challenge to turn that mess into a high-purity powder that a defense contractor can actually use. That is where the story moves from the creek bank to the laboratory. The process they developed is nothing short of industrial alchemy. Traditional rare earth mining is a nightmare. You have to dig up massive amounts of rock, crush it into dust, and soak it in harsh chemicals. It is expensive, energy intensive, and often dangerous because these rocks like to hang out with radioactive elements like thorium. That is one reason the United States stopped doing it. It was just too much trouble. But river mining skips the hardest steps. The acid mine drainage provides the metals in a liquid form. The problem is that the liquid is also full of iron, aluminum, and other stuff we do not want. If you just treat the water the old way, everything falls to the bottom in one big, messy pile. Separating the rare earths from that pile is like trying to get the sugar back out of a baked cake. So, the engineers came up with a brilliant fix. They called it the two-step process. Here is how it works. First, they take the acidic water and add just enough lime to raise the pH to a specific level, right around 4.5. At this point, most of the iron and aluminum turn into solids and drop out of the water. But the rare earths stay dissolved. They are stubborn. They like to float. Then, they take the cleaner water, which still holds the rare earths, and raise the pH again, this time up to around 8.5. Now, the rare earths finally surrender. They drop out of the water and settle at the bottom of the tank. By splitting the process, they create two different piles of mud. One is just regular waste, but the other one is a super concentrated sludge rich in critical minerals. It is brilliant because it uses the existing water treatment plants that were going to be built anyway. At the Richard Mine near Morgantown, you can see this machine in action.
And it's an area that's been heavily mined for coal since the Civil War.
The engineers separated the flow. The valuable sludge gets pumped into massive white fabric tubes called geotextile bags. They look like giant pillows resting on the ground. The water slowly drains out through the fabric, leaving behind a thick, heavy paste. Tests show that once this paste dries out, it is incredibly potent. But the journey does not end there. That dried mud is just a concentrate. It still needs to be refined. Trucks carry this material to a special facility where the real magic happens. Workers dissolve the mud back into acid and run it through a system called solvent extraction. Think of it like salad dressing. You know how oil and vinegar separate in the bottle? They use a special oil-like liquid that is chemically designed to grab onto rare earth metals and ignore everything else. They mix the water and the oil together. The rare earths jump into the oil. Then they let it settle, and the oil floats to the top, carrying the treasure with it. They do this over and over, washing the liquid until they have a solution that is 99% pure. The result is a fine powder called rare earth oxide. This is the stuff that gets sold on the global market, and the amounts we are talking about are serious. At just one treatment site, researchers estimated the rare earths flowing through the system could be worth $1 million over time. Now, multiply that by hundreds of treatment sites across West Virginia, Pennsylvania, and massive pits in Montana like the Berkeley Pit. We are looking at a network of man-made mines that are cleaner, faster, and cheaper than anything we could dig out of the ground. And everyone is obsessed with the fact that these sources are rich in the heavy, rare earths. These are the specific types, like dysprosium and terbium, that are essential for high-temperature magnets in electric vehicle motors. They are the hardest ones to find globally, and usually, we have to rely on very specific mines in China to get them. This technology proves we can make our own. We can turn 100 years of pollution into a strategic stockpile. The pilot plants are running. The magnets are being tested. The science is solid. But just as this solution is coming online, the problem it solves is getting much worse. Because while American scientists were busy figuring out how to clean up their rivers, the government in Beijing was making moves to ensure they stay the only player in town. We found the treasure, but now we have to defend it. Magnets, missiles, and the fight for control. To understand why a muddy creek in Appalachia matters to the Pentagon, you have to look at the big picture. For the last 30 years, the United States slept while China built an empire. Washington was happy to let China do the dirty work of mining and processing these metals. It was cheap, and it kept the pollution overseas, but that convenience came with a terrible price. Today, China controls nearly 90% of the processing for rare earth elements. They make almost all of the magnets used in the world's electronics. This gives Beijing a switch they can flip whenever they want, and recently, they started flipping it. In April of 2025, after the United States put tariffs on Chinese goods, China fired back.
If you look at that, China, first row, China, 67%, that's tariffs.
They placed strict export controls on 7 key rare earth categories. Suddenly, companies in the United States and Europe could not get the materials they needed. Shipments were delayed, licenses were denied. It sent a shockwave through the industry. Automakers panic-bought supplies. Defense contractors started looking for alternatives. But it did not stop there. Later that same year, China tightened the screws even more. They did not just ban the metals, they banned the export of the technology used to process them. Basically, they told the world, not only will we not sell you the product, but we will not let you learn how to make it yourself. This is a classic chokehold. Beijing knows that the green energy transition, all those wind turbines and electric cars, depends entirely on these magnets. They also know that the United States military needs them for night vision goggles, communications gear, and nuclear submarines. By restricting access, they are using their geology as a weapon. They say it is for national security, but most experts see it as leverage. They want to force the West to stay dependent. That is why the river project is so critical. It is not just about economics, it is about survival. The Department of Energy is pouring money into these acid mine drainage projects because they represent a supply chain that China cannot touch. They cannot block a river in West Virginia. They cannot sanitize a treatment plant in Montana. This domestic source is what experts call unconventional. It is not a mine that can be bombed or a trade route that can be blockaded. It is distributed across thousands of miles of American territory. So, here is the deal. We are in a race. China is trying to lock down the market before the rest of the world can catch up. The United States is scrambling to turn its waste into independence. Every bucket of sludge that gets processed in Morgantown is a small victory in a much larger silent war. It proves that we do not need to rely on a rival superpower to build our own future. The irony is massive. The coal industry powered the American Industrial Revolution in the 20th century. Now, the pollution left behind by that industry might be exactly what saves the American technology revolution in the 21st century. But the question remains, can we scale this up fast enough to matter? Or will the export bans strangle our high-tech industries before we can get the mud out of the water? So, the next time you see a rusty orange stream, do not just see pollution. See the raw power of a fighter jet waiting to be harvested. But is it enough to break China's grip on the world? Tell us what you think in the comments. Like and subscribe for more stories about the hidden wars for resources.